Hi everyone, I hope you guys are doing well. I hope you guys had a great weekend and a great snow day. That was so awesome. So I decided to do a pedigree video for you so that if you are struggling with pedigrees, you can look at this video, you can rewind it, you can fast forward, you can pause it, whatever you need to do to understand pedigrees. Hopefully this helps. I'm going to go over 2 pedigrees and hopefully you'll understand them a bit better after this video. And you can always rewatch the video if you need to, or rewatch what I say about certain concepts. So I'm going to go through the step-by-step process that I go through in my mind when doing a pedigree. If you want to get out a separate sheet of paper to write this stuff down, you can. I do recommend taking notes because that'll help you understand it a bit more. When you write it down, you remember things a little bit better. But you don't need to write down the steps if you don't want to. So step 1, the first step that I go through in my mind is that I need to determine which one is recessive, the shaded or the unshaded. That's the first thing that I need to do. Once I figure that out, then I could just fill in the genotypes of all of the people that have the recessive trait. So that's pretty easy. Those first 2 steps are pretty easy, and I'll show you how you can figure those out easily. Step 3 is to figure out the genotypes of the people with the dominant trait. Now, this is the hardest part. The dominant trait is hard because you have heterozygous and homozygous dominant, and so you got to figure out which one is which based on the kids that they have. And then step 4, you just write a key for the phenotypes. You can actually put the key, you can actually make this even step 2, but I'd say most of this is pretty easy. I think the hardest part is just figuring out the people with the dominant trait, like what their genotypes are. So we're going to go ahead and do our first pedigree. So let's go ahead and do it. Alright, so here's our first pedigree. Now, I've tried to do a simple pedigree to begin with. We need to figure out which one is dominant versus which one is recessive, the shaded or the unshaded. So I always think about it as which one is recessive, the shaded or the unshaded. Now, you can't go by what's most common because dominant isn't always the most common. Recessive can be a little bit, you never know. So the best way to figure it out, the most reliable way to figure out which one is recessive, you need to know the concept that 2 people with the recessive trait cannot have a kid with the dominant trait. Okay, so I'll repeat that. 2 people with the recessive trait cannot have a kid with the dominant trait. So I'm going to show you that with a Punnett Square. So if you want to do this Punnett Square with me, you can. Actually, in fact, I would pause it and I would actually draw this out. So go ahead and pause it and draw this out, and then we can resume. Once you have drawn this, we are doing the trait detached versus attached earlobes, right? So like I said, 2 people with the recessive trait cannot have a kid with the dominant trait. All right, so, and I'm going to show you why. If we did a Punnett Square, okay, and let's say both parents had attached earlobes. Attached earlobes is the recessive trait. So that means they're little a, okay? So if I were to bring this down, if I were to do the Punnett Square, hopefully you guys are good with Punnett Squares by now. I know Punnett Squares are a little difficult, especially learning in hybrid learning. Okay, so if I were to do a Punnett Square between 2 people with the recessive trait, attached earlobes, notice how they can only have kids with attached earlobes. All right, so they can't have a kid with the dominant trait. Now, unshaded is either recessive or dominant. Shaded is either recessive or dominant. So we got to figure that out. So would it work? Now, I don't want you to write this yet, but I'm just going to show you. Would it work if both of these parents had the recessive trait? Would that work? So think about that. Think about if it would work. If you think that it would not be possible for both of them to have the recessive trait, you are correct. Because if that were the case, then all of these would be shaded, okay? Because shaded would have represented recessive. So because it's not possible for them to have the recessive trait, we know that shaded is actually dominant. So hopefully that makes sense. Shaded is dominant, unshaded is recessive. Because again, if these 2 had the recessive trait and they both had attached earlobes, they would not be able to have kids. They would not be able to have both unshaded and shaded kids. It won't work because of this Punnett Square. Okay, so we know these 2 are dominant. We know that the unshaded is actually the recessive. So unshaded is recessive. So we're actually going to fill in the genotype. So step 1 was to figure out which one was recessive, the shaded or the unshaded. So we figured out that the unshaded ended up being recessive, right? So we're going to go ahead and fill in the genotypes of all of the recessive people with the recessive trait. So we got those genotypes in. We know that they have the recessive trait. We know that these children have the attached earlobes. We know that the parents have detached earlobes. Okay, now it's a matter of, are they heterozygous or are they homozygous dominant? So they're either homozygous dominant or they're heterozygous. So which one do you think they are? Well, let's find out. So if we were to do a Punnett Square, let's say that one of them is heterozygous, right? We'll do a Punnett Square to figure this out. Let's say that one of them is heterozygous. You can test this out because you know at least 3 of their kids. You know at least they had 3 of their kids have attached earlobes. So let's say one of them is heterozygous and one of them is homozygous dominant. So if you had one parent that is heterozygous and you have one parent that is homozygous dominant, is it possible for them to have a kid with the recessive trait? Let's find out. So if you were to do a Punnett Square and you were to bring the big A down, and then you were to bring the little a down, and then you were to bring the big A over, and this big A over, would it be possible for them to have the recessive trait? Or a kid with the recessive trait? No. You don't see little a in any of these boxes. So it's not possible. Okay? But let's say that, so the only other possibility is, let's try big A, little a, with big A, little a. Let's try that. You know both parents have to have at least a dominant trait because shaded is dominant. Okay, so let's go ahead and try that. Big A. We're going to bring that down. We're going to bring the little a down. We're going to bring the big A over. And then we're going to bring the little a over. Now, here you go. There's a 25% chance that they'll have a kid with attached earlobes. They ended up having 3 kids with attached earlobes. So what are the odds? But there's still that chance, right? So actually, both parents are big A, little a. So sometimes you got to do Punnett Squares to test your answer. Now, me doing pedigrees for a little while, I didn't have to do a Punnett Square to figure this out because I know that these kids had to have gotten a little a from their mom and they had to have had a little a from their dad. So all I need to know, so you can't have homozygous dominant because you wouldn't have been able to get a little a from one of the parents. So I know that one of the little a's had to come from the mother and the other that's the father. So square is male. So one of the little a's had to come from the male and one of the other little a's, the recessive alleles, had to come from the mother. Okay, so I knew right away that they were heterozygous. Alright, so now we need to figure out this guy. So this guy is dominant. So he inherited the dominant trait from his family. Now, looking at this Punnett Square with his mom and dad, can we know what his genotype is? Can we know what his genotype by looking at this Punnett Square? We can't know his genotype. Now, the reason why is, if you guess that, the reason why is there's a 50% chance that he could be heterozygous, and then there's a 25% chance that he can be homozygous dominant. We're not sure because he hasn't had kids yet. He can get a genetic test and figure it out, although that would be really silly for whether you have attached or detached earlobes, but we're not sure. Because there's 2 possibilities with these parents. So if there's ever 2 possibilities, he can either have big A, or big A, little a. So there you go. We figured out the pedigree. The next part is you get asked for phenotypes. So this is the genotype. Genotypes, the thing that helps me with genotypes means genes, so the alleles represent the genes, genotype. Phenotype is the physical characteristic, pH, they both start with pH, and so that's how that helps me. So if we were to do a key for the phenotype, so I'm going to move this paper a bit, we're going to go ahead and write phenotype. Okay, so now that we have phenotype, we're just going to do shaded represents and then unshaded represents. Okay, so first off, just look at this. Is shaded dominant or recessive? So we talked about this. If you said dominant, you are correct. It's dominant, right? So shaded is dominant. So which would they have? Would they have detached earlobes or attached earlobes? You're very smart. They would have detached. Good job. So go ahead and just write detached earlobes. You could just say detached. And then the unshaded. Would they have detached earlobes or attached earlobes? Nice job. They would have attached. Okay. So they would have attached earlobes. And there you go. So I decided to start off with an easier pedigree, and hopefully this helps you. If you need to rewind it to just like rehear the concepts, then do that. The more you repeat and the more you rewatch, the more you'll remember it. So whatever you need to do to remember this, you can also speed up my voice. Also, that'd be kind of funny. I don't know if it would. I actually would like to see. I should speed up my voice on my videos and see what it sounds like. So I'm going to go ahead and do one more pedigree. So let's go ahead and do that pedigree. All right, here's the last pedigree that we'll do together. And then hopefully that's enough practice. All right, so first off, we need to figure out which one is dominant. Remember, you got to go through those steps from the beginning. If you need to rewind the video and write those steps down, then do that, because I think those steps really help. So that's the first thing that you need to do. Which one's dominant versus which one's recessive, the unshaded or shaded, okay? So if we look at this, actually, I think this one could tell you. So remember, recessive, two people with the recessive trait cannot have a kid with the dominant trait, right? So we did that little a, we crossed little a with the other little a. And I'll go ahead and do that again for just to repeat for you. And you're always welcome to make my voice go faster if you want. So I'm going to bring down the little a, bring down the little a, bring over. That's the beauty of videos. You can fast forward, you can rewind, you can do whatever you need to do. So we know that two people with the recessive trait cannot have a kid with the dominant trait. Shaded and unshaded, they're either recessive or dominant. So right here, we have two people that are having both kinds, dominant or recessive, okay? So what do these two people have to be? What does unshaded have to be? Are they dominant or are they recessive? Can they be recessive? Can they both be recessive if they're having two different kinds? No, they cannot be recessive. So in this case, the unshaded is dominant, okay? And that means the shaded is recessive, all right? So hopefully that makes sense. You can't, both of these parents cannot have little a, little a. They can't have little a, because if you were to do a cross, they can't have both kinds. That would mean that this was dominant and they can't pass on the dominant trait. So that's not right. Whoop, that's not good. So don't make sure you don't write that. So we know these are dominant. The shaded are recessive. Okay, so we're going to go ahead, the second step, fill in the recessive trait for the people that are recessive in the pedigree. Okay, so we did that. That's the easy part. Now we got to figure out the dominant, all the dominant people. Ooh, there's a lot here. So this will be good practice. So we can actually go ahead and let's do this one first, okay? Now, I know just by looking at this what these two parents are. Do you have an idea? We kind of did it in the last one. So I know for sure that these both of these parents are heterozygous. So you can go ahead and write that. And the reason why I know they're both heterozygous is because they had a kid with the recessive trait. So each parent had to have passed down a recessive allele. Each parent had to have passed down a recessive allele. You can't have a parent that's homozygous dominant because it would be impossible for them to have a kid that has a recessive trait. And I'll show you again, if you had a parent that was homozygous dominant and you had a parent that was heterozygous, I'll go ahead and do this Punnett square. It's not possible for them to have a kid with the recessive trait. There's no little a in any of these boxes. So I know for sure that both of these are heterozygous. And the easiest way to figure that out is the little a gets passed on from a mom, and the little a recessive trait gets passed on from the father. Okay? So there we go. And again, so over here, let's look at this one. This one's not too bad either. They ended up having a kid with the recessive trait, right? So I know for sure that both of these are also heterozygous, right? Because they had to have passed down, each parent had to have passed down the recessive trait, right? So hopefully that makes sense. None of these parents can be homozygous dominant. They would not be able to have a kid with the recessive trait. They would not be able to have a kid that has attached earlobes. So we're doing attached earlobes again. Attached versus detached. Now, let's go ahead and get to these parents and this kid. This one's a little bit more difficult because they didn't have any kids that have the recessive trait. Okay? So it looks like they had a girl and 2 boys. Okay? And so it looks like their first child was heterozygous and their third child was heterozygous. We're not sure what this child is. So let's go ahead and figure this out. Now, we know that unshaded is dominant, right? So we know that unshaded is dominant. It's a matter of, are these guys heterozygous or homozygous recessive or homozygous dominant? Okay? So, if we did a Punnett square, and I think doing Punnett square to check your answers is always good, especially if you struggle with pedigrees. I think it's always good to do these Punnett squares. And let's say both of them are heterozygous. Alright, so I'm going to bring the big A down. And then I'm going to bring the little a down. And then I'm going to bring the big A over. And then I'm going to bring the little a over. So, could both of these parents be heterozygous? Could they both be heterozygous? If you said yes, you are correct because, first off, they had 2 kids that are heterozygous, right? So that's possible. There's a 50% chance that they can have kids that are heterozygous if they're both heterozygous. Okay? Now, we know that it's possible for them to both be heterozygous. Can one of them be homozygous dominant and the other one be heterozygous? So let's go ahead, just for practice sake, let's do a Punnett square. We'll do one that's homozygous dominant, and then we'll do the other that is heterozygous. I'm going to bring down the big A, and then bring down the big A, and then I'm going to bring over the big A, bring over the little a. Is it possible for one of them to be homozygous dominant? Yes, it is. It is possible. Okay? So, they both can't be homozygous dominant, though. Because if they were both homozygous dominant, everything would be homozygous. All of their kids would be homozygous dominant, and that's not possible because they just had kids that had the recessive trait. So one of them is homozygous dominant. Okay. If there was we don't know if the mom is homozygous dominant or if the father is homozygous dominant. They could both be heterozygous. I don't know. So we'll say big A, little a, or big A, and then we'll say big A, little a, or big A. And then on the side, what we can do is we can say both can't be big A. Only one of them can be big A. But, I don't know if the mom is big A, or the dad is big A, or they both can be heterozygous. But both cannot be homozygous dominant. because then it would not be possible for them to have a kid that is heterozygous. Okay, so if we're kind of unsure about whether or not, it doesn't matter actually. Can we know what this child is? Can we know if they're big A, or big A, little a? So go ahead and think about that, looking at the Punnett squares. So these are the two possible Punnett squares. These are two possible ones. Can we know if this kid is big A, or big A, little a? Can we know if it's homozygous dominant or heterozygous? If you said no, you are correct. We can't know because over here, if one of the parents is homozygous dominant and the other one is heterozygous, they have a 50-50 chance of having a kid that is homozygous dominant or heterozygous. Over here, if they're both heterozygous, there's a 25% chance that they can be big A, which is homozygous dominant, or heterozygous. Okay? So we don't know for sure. And so whenever we don't know for sure, this guy hasn't had kids yet, so we're not really completely sure. So we're going to go ahead and say big A, or big A, little a. We're not really sure. There's not enough information in the pedigree to know. So if you need to review this video, if you need to rewind it, make sure you do. Now, let's go ahead and do the phenotypes. Remember, any multiple choice test, when we're asking for phenotype, we're asking for the physical characteristic. Okay, so let's go ahead and do the phenotype. We'll just do a key. And then so the shaded. Okay, first off, is the shaded recessive or is it dominant? If you said recessive, you are correct. And it's okay, so recessive, is that detached or attached? You're so smart, good job. It's attached. Alright, so the shaded is attached, earlobes. We'll just say attached. And then the unshaded would have to be detached, right? The unshaded is dominant, so it's detached. Well, I tried to explain it the best way that I could. Hopefully it made sense. If you need to rewind it, rewind it. I know these pedigrees can be overwhelming. I mean, look at all the Punnett squares we did. A lot of them can either be big A, or big A, little a. So just make sure you understand why that's the case and why we can't know for sure one or the other and why we can know for sure with these. But hopefully that helped. Hopefully I gave you some good examples. One key thing is shaded is not always dominant and shaded is not always recessive. You gotta look at each pedigree and look at what makes sense. You can't assume that shaded is always recessive. And I think a lot of students might make that mistake. So you always got to figure out which one is dominant and which one is recessive. Okay? So make sure you always go through those steps. And hopefully that helps you. I hope you guys have a great day, and hopefully this helped. Bye, guys!